Hello everyone. Today I'm going to talk about the effect of pollution on parasites. What does pollution do to the parasites? Pollution can affect the parasite fauna of its definitive host in various ways. A polluted environment can affect the definitive host itself, or it can affect the intermediate host of the parasite. Aquatic pollution may affect the parasite fauna of a definitive host directly by 1. Acting on the free-living parasite stages, or 2. The ectoparasites attached to the host, or 3. Indirectly by acting on the intermediate or the definitive host population. Dams or artificial reservoirs lead to the build-up of certain oligochaete and copepod species that are intermediate hosts of fish cestodes. Building of the dam at Tasik Kenyir has led to the increase in copepod abundance, resulting in the increase of the cestode Senga species in Toman or Ophiocephalus micropeltis. This is the synergistic effects of parasitism and pollution on host survival. Water pollution and certain parasites potentially are fatal to aquatic organisms. A combination of both factors will magnify the risk of dying. This is the identification of the cestode from Toman or Chena micropeltis, and it is a potential as a bioindicator for aquatic heavy metal pollution. The Scolex has got apical hooks A and B, and this is seen under the scanning electron microscope or SEM. The arrow in A indicates the apical hook. The arrow in B indicates the apex of the hooks. The cestode Sangapava from Chana micropeltis at Tasik Kenyir was identified. And this parasite differed from other species of the genus Senga, parasitizing the fish genus Chana, by the size of the strobila, the scolex, the apical disc, the hooks, the number of hooks, the number of testes, and some other characteristics. Now, acanthocephalans are also pollution indicators. For example, Pomporhynchus levi most rapidly react to changes in the environment. And parasites can also be indicators of aquatic pollution. And this is evidence from field surveys carried out by Cooper and Keller in 1969 in California. And we find that Perking, Gilchrist and Abbott in 1972 also carried out in the Irish Sea and supposed that the presence of anthropogenic pollutants might be one of the contributive factors for the outbreak of fish diseases in the sea. They carried out hundreds of experiments and field surveys to prove and to quantify the effects of toxicants on fish health. This is a field study carried out in Germany by Moller in 1982. He showed that he carried out transects along the river Elbe, and he showed that the concentration of most pollutants decreased towards the estuary due to dilution processes. And figure 5 show biological data of the 3 dominating fish species from the Elbe River, and disease prevalence are given in percent and refer to flounder, eel and smelt. And all the data are averages for the period February to November 1982 based on monthly sampling. For further details, you can go to Moller, 1982. Now, in figure 5a, the disease is caused by viruses or microorganisms and triggered by environmental stressor which occur in the central estuary. And figure 5b show granulomas in the mouth of smelt, which is food induced due to the reaction of host tissues to amphipod spines. Figure 5c are the skeletal deformities that manifest mainly during embryonic and larval development. Marine and euryhaline fish in the Elbe estuary are infected by a number of ectoparasites like the copepod, the Neisseria branchialis, and also Lepidopterus pectoralis. And also the fish has got large whitish nodules due to the virus lymphocystis. Kiesecker reports field and laboratory studies that conclusively demonstrate that trematode infection was required for deformities in certain frogs, okay? And these deformities were more common at sites adjacent to agricultural runoff. And the laboratory studies corroborate the association between pesticide exposure and increased infection with pesticide-mediated immunocompetency as the apparent mechanism. This is the latest work from Malaysia, and it shows the effect of metal pollution on the fish and also on the parasite cestode senga species. So the concentration of the tissues and the for example, in the cestode, the lead concentration is higher compared to the ones in the tissues. The fish has got large whitish nodules due to the virus lymphocystis. Kiesecker reports field and laboratory studies that conclusively demonstrate that trematode infection was required for deformities, and these deformities were more common at sites adjacent to agricultural runoff. The laboratory studies corroborate the association between pesticide exposure and increased infection with pesticide-mediated immunocompetency as the apparent mechanism. The latest work from Malaysia, figure 1 shows the concentrations of metal in fish tissues and cestodes. A, concentration of lead is higher in cestode compared to fish tissue. B, concentration of copper is higher in fish tissues. The concentration of zinc, manganese and cadmium is higher in cestode compared to the fish tissues. pollution has an effect on parasites, but some metals can be absorbed by the parasites. Hence, if you eat fish which has lots of parasites, possibility is that the fish has less metal pollution because the metal has been absorbed by the parasites. Thank you for watching and hope you learned something from this video.